Hey guys, Dexter here from Dexter's Workshop. For 2 days now, I've started to work on a new project that should measure some weights via a load cell. This one it's rated 1 kilogram, and it's also a low power application. So the biggest challenge was the fact that I couldn't actually measure the weight all the time on this particular load cell because I wouldn't have a reference, and this is because after a certain time the microcontroller and all the system is powered down completely to save power. So I had to come with a method that would allow me to measure the weight on this load cell even if the system wouldn't be powered up, so I can have a reference, an initial reference. The problem was not the fact that I had to measure the weight that was applied on this load cell, but the weight is also changing during normal operation. And based on the measured weight, I'm taking some decisions regarding the, I don't know, alerts and stuff like this. So the way I've made up through this initial process, I just realized I need a calibration routine and an initial value for which I would have to use during the calculation of the weight. So the best way to do it is having a calibration routine. At least it was the only way I could do it. And this calibration routine takes place one time and can be called as many times as you like. And you can do this from user point of view by pressing a button, by keeping a button pressed while the system is started, and not having any weight on the load cell. Of course, you will have to have some kind of board on which you'll have to put your materials, but that will represent the zero weight. So the best way to do it is take an initial value and have it stored in your memory. Initial value that actually can have any number. So you measure this at startup. At this particular moment, the pin is held low, and we are going up with the calibration routine by powering it up, going up. It will measure calibration values with an average of 50 samples, and this is just a number. It does not represent anything. As you can see, at this particular moment the weight is 0 and the system is powered down. At this particular moment the calibration routine is finished. You can take out the pin, which in the final product will be a switch, which can be accessed by user. And you can, however, put a weight on the scale, and I'm trying to do this one hand only. So I'm going to take, let's see, some kind of bottle that I have here. It says 100 milliliters, but it's already consumed, and I'm going to put it on my load cell. Okay, and it weighs 93 grams. That's about correct. And the system is going to power down again. And if I'm going to change the weight on the load cell, you will see that the measurement, it's also taking place with the new weight. We will have to wait around 1.5 minutes, because after 1.5 minutes the system will wake up, take a measurement, then go back to sleep again. I don't know, I don't have a beautiful story to tell you during this timeout and this power down. So around, okay, it's 23 grams, and so on and so on. As you can see, at this particular moment, the current required is 0. The value of the standby current is around 25 microamps, and you will see when the system is up and running, it will be around 140 milliamps. That's about 0.14 amps, which is okay for a battery powered device, because it will take only 2 seconds or something like this to take that particular current from a battery. And according to my calculations, a battery should last, a lithium ion battery of 2 amps hour should last quite a lot. Okay guys, thank you for watching. This is Dexter from Dexter's Workshop. I hope you enjoyed it, and I will keep you up with the progress.